Okay, let's do another type of mixture problem. And when it comes to mixture problems, feel free to use this template right here. Like I said before, if you ask 5 different people how to solve a mixture problem, just like a distance time velocity type problem, you probably get 5 different ways. Yeah, I don't know if I can prove this, but this is probably the easiest way. But you know, you can do it a different way if you want. This is definitely the most elegant way, or in some way satisfying way. Okay, so keep this in mind. Actually, I want room on the board right now, so I'm going to erase this. But see this template right here? Remember, the A stand for amount, the C for concentration or cost. No need to memorize that. I mean, I get it. You're taking your test, so you can have your notes in front of you. Even an in-class test, I don't require my students to memorize that. Okay, so let's suppose that you run a coffee shop and you've done it for a long time and you know all about coffee. You're the coffee expert. And you went to some big coffee convention. And there, someone was touting, selling the world's greatest coffee. And you had a sip of it and it was amazing. It was beyond belief. Um, so you bought some. Um, but then when you got home, you thought, what was I thinking? Because that was unbelievably expensive. So let's say the cost of this coffee was $100 per pound. It's a heck of a lot of money. And you happen to have bought, let's say, 30 pounds of it. So what are you going to do with it? No one's going to buy it. I don't care how tasty it is. Nobody's buying coffee for $100 a pound. So you hatch an idea, and the idea is you'll blend this, you'll mix it, or blend it, or I don't know, can't think of another synonym right now, but you mix or blend the expensive coffee with your cheap coffee, which is, let's say, you get for $2 a pound, and you have an unlimited amount of that. So here's the problem. Oh, wait, one more thing. Thanks. You think you're going to make, or you decide to make a holiday blend, okay? Um, and you feel, based on your experience and your expertise, that you could sell this for, let's say, $5 a pound. So let me recap the problem. You've got 30 pounds of this incredibly tasty and incredibly expensive coffee, and you want to mix it with 2 pounds of your standard house coffee to achieve a blend which you would like to sell at $5 a pound. The obvious question is, how much of the cheap stuff, how much should you mix with the expensive stuff so that you get a blend that would sell for $5 a pound? Again, it sounds like a really complex problem. Maybe in some way it is, but if we use that template, it becomes almost trivial. And I'll re-clarify what I mean by almost trivial. But if you look at that template, which you should have in front of you, what's the amount of the first stuff? 30. What's the amount of the mixture? We don't know. That's where, or sorry, well, we don't know that either, but what's the amount of the cheap stuff? We don't know. Now here it seems a little silly to write down a sub 2 is just the amount of the $2 coffee, but here I'm really using that template, amount of the first stuff, amount of the second stuff, and then what's the amount of the mixture? Well, we don't know. We don't know how much that's going to be. Now here's where I can use cost for C instead of concentration. What's the cost of the first stuff? 100. What's the amount? 30. What's the cost of the second stuff? $2, because $2 a pound. What's the amount? We don't know. What's the cost of the mixture supposed to be? 5, and the amount we don't know. Now, when I said trivial, what I meant is we're done. That's provided you can, so here's the catch, here's the caveat. That's provided you can solve 2 equations and 2 unknowns. This is the way oftentimes the 2 equations and 2 unknowns comes up. You'll struggle through some kind of a problem. It doesn't have to be a word problem, but struggle, and then you're confronted with the 2 equations and 2 unknowns. And this comes up, like I said, all the time. So remember I said I'm going to throw in a few historical things concerning math and physics, which are really tied together. and continue to be tied together. Um, During World War II. This is strange because I'm so used to having a class of students, and I would ask everybody, what did Alan Turing do? And most people don't seem to know, though more people know now than would have 10 years ago. Because frankly, they made it as a big Hollywood motion picture that involved Alan Turing. But Alan Turing was a mathematician, and he broke German codes, actually particularly a main code that used something called the Enigma machine. But at any rate, he broke German codes during World War II. And to do that, he realized no problems. I mean, he was a brilliant individual, but let's put it mildly. But he realized I can do it. I can break the German codes, no problem. All I have to do is solve 50 to 100,000 two equations and two unknowns. And they're changing the codes every couple of days. So you've got, let's say, 2 days, solve 50,000 of those. No human can do that. Can't do it. So what did Turing do? Designed and helped physically build the world's first computer. And this was, I think, maybe 1943, 42, at any rate, early 40s. Alan Turing. You'll notice if you Google changes their font when you go to Google for important events sometimes, and it seems to me that every year on his birthday they incorporate Alan Turing in there, which makes sense because no computer, no Google. We could talk more about Turing. The Imitation Game was the movie, which more or less adhered to the facts. It was pretty factual, pretty straightforward. If you happen to watch it, the young mathematician named Peter Hilton was one of my professors, actually, in grad school, and I was working on a PhD. Okay, now, I'll give a couple other famous examples in other videos about two equations and two unknowns. A guy named Roebling, can't remember his first name. Actually, it was father and son, but the son in particular, who finished the building, the design and the building of the Brooklyn Bridge, had to solve tens of thousands of these by hand. That was in the late 1800s. But I'm not going to test you anything on Roebling. But we could go on and on and on. There's no end of uses of two equations and two unknowns. So the mixture and the velocity, those are just two, but there's thousands and thousands of very real world problems. Now, the reason I'm doing this is I'm going to do an example of a type of problem. And I'm only going to do one example, and you'll see why when I'm finished. And it's the kind of thing, the kind of problem you want to make sure that you're well rested, or at least able to focus for some period of time. And this is a three equations and three unknowns problem. So instead of a two equations and two unknowns, it's three equations and three unknowns. And I want you to be able to do this by substitution. This is a bit unusual. If you went to YouTube and typed in, search for two equations and two unknowns by substitution, 100,000 examples. I mean, there's no end of examples. Fine. There aren't many of three equations and three unknowns with substitution. They use a different method, which we're going to talk about probably in the next video. Because in the next video, I want to talk about alternative methods for solving systems of equations. But for reasons I don't think that I've necessarily explained yet, maybe I have, I think learning the substitution method is by far the most important thing for you to learn when it comes to these systems of equations. Now, I want this system of equations to come out nice. In the real world, they would almost never come out nice. But right now, I want the numbers to be relatively tame. So I'm going to show you the answer up front. Fine, because I'm going to make up the answer right now. I'm going to have x equals 3, y equals -2, and z equals 1. Now, you're not supposed to see that, right? So this is, again, I'm starting this out sort of like the making of, and you're not supposed to see that, but I want the answers to come out nice, so I have to pre-make this, or I have to consciously make this. in a specific way so that we get very nice answers. So, and again, I'm going to write down some other numbers right now. I'm picking them not entirely at random. I'm picking them so that the problem stays fairly nice. So let's say we have 2x plus 3y plus 4z. I'm not happy with that 3 for reasons I won't get into here. Now, this is a making up, right? So we know the answer. So that would be 6 and negative 10, right? So, you know, I mean, 2 times 3 is 6, and 5 times negative 2 is negative 10. So 6, negative 10 is negative 4. Wow, I can't, here, let's make this a 3. There we go, 3. So this would be negative 1. There's nothing wrong with the other choices. It'd be fine. But I want to make a problem which is easy, but also completely general. In other words, I want to have an example so that what I do on this problem will apply to any problem you encounter. Okay, let's say we had 4x plus 2y plus, let's say 5z. Let's see what this comes out to be here. So 12 and negative 4 is 8. 8 plus 5 is 13 now. The reason I sighed, I want to try to avoid unpleasant numbers here, which they tend to crop up automatically or to be incorporated almost without question in these problems. Believe it or not, notice here 2, 5, 3, 1. I'm really trying to get numbers that are single digit whole numbers. We can live with 13 though. It's not too horrible a number. So here, let's say we have negative 2x minus 4y plus 2z. Now, would this be negative 6? And then this would be 8. So that's 2 plus 2 is 4. Okay. Now remember, you were not supposed to have seen that. Now, how do we do this problem? We're going to do it by the substitution method. And you can break it down into a series of relatively simple steps with a couple exceptions. First step is pick an equation and solve it for one of the letters. It doesn't matter which equation you pick. You choose. If one of the equations looks easier, start with that one. Here in this case, they all look about the same. I don't see a particular advantage of starting with any of them. I'm going to start with the first one. I'm going to solve it for z, and I'll show you in a second why I'm going to solve it for z. But you can solve for x or solve for y. That's your choice. You'll still get the same final answer. So again, you can choose any of the 3 equations, your choice. Solve it for any of the 3 letters, your choice. So let me take the first equation, solve it for z. We can subtract 2x and 5y. So I don't have a lot of room to work here, but so this arrow it's not a mathematical symbol. I'm just trying to say this first equation becomes, when I subtract 2x and 5y from both sides, we have 3z equals negative 1 minus 2x minus 5y. And let's divide both sides by 3. So we get z equals negative 1/3 minus 2/3 x minus 5/3 y. Now there's step 1. Not too bad. Not too bad. Step 2. You substitute this in the remaining 2 equations. So if I started with the first one, I'm going to substitute in equation 2 and 3. If I started with equation 2, I'd substitute in equation 1 and 3. But the remaining 2 equations. So let's take this here and substitute it in for z. There. Now I'm not going to do any math right now. I'm not going to add. I'm not going to subtract. I'm not going to divide. I'm not going to multiply. I'm not going to distribute. I'm not going to do any math, but I have to be extremely careful that I copy everything down right, at least for me. Can't tell you how many times I've copied something down wrong. It's very easy to be blind to your typographical mistakes, and you can't see the typographical mistakes you made. Okay, so let me go ahead and do that. So 4x plus 2y plus 5, and then So there, see this equation right here? Right there, I copied it down, but I made the substitution for z, and I want to do the same thing here. Negative 2x minus 4y plus 2 there. There's the second move, step 2. Don't do any math on that step. Don't do any math. Just copy everything very carefully. I'm going to erase, I don't want to erase this. This is where I am in the problem. I'm going to need this equation here again, so I'm going to keep this one at the very top. You can always review if you want to go back and take a look at this stuff. Let me erase all this here. Okay. What do you see right here? It's 2 equations and 2 unknowns. 2 equations and 2 unknowns. But they're not very user-friendly, 2 equations and 2 unknowns. They're not very pleasant, 2 equations and 2 unknowns. So what I suggest you do next, although you don't have to, but I really suggest you do this next, is simplify these. They're too horrible to work with as they are. So let me simplify. You can work in any order you want, but let me simplify this one first. So at any rate, hey, let's go ahead and do the distributive rule here. So negative 2x minus 4y. I'm going to do the distributive rule. Why am I going to do the distributive rule? Because I always do the distributive rule. When it's there, I do the distributive rule. So here we go. Minus 2/3, minus 4/3 x, minus 10/3 y equals 4. Notice up till now, we haven't had to really do very much math. The math has been very, very easy. This is probably where most people will bog down. And why will they bog down? Because they have to add or subtract fractions. So don't let the fractions get in your way. Just kind of cope with them, you know. Let's add like terms. So then that negative 10/3 x, negative 4y, minus 10/3 y, negative 22/3 y equals 4. I want to write this equation where I can work with it. Remember, I'm going to need this, so I'll just box it in. But this right here, negative 10/3 x minus 22/3 y equals 4. I'll probably say this a few more times. The way I'm formatting this problem, there's nothing special about it. It usually just depends on what sort of board or piece of paper I'm working on. The order of the steps is the same, but the way that I format or write down these steps on a piece of paper to some large extent is due to, not entirely, to the paper that I have or the board I have in front of me. Okay, so we've simplified this. Now it has that standard form of 2 equations and 2 unknowns that you've seen. And hopefully you practiced a lot of problems out of the book to where you feel like you can absolutely do 2 equations and 2 unknowns. Let's do the same thing here. Okay, what do we have? 4x plus 2y minus 5/3. This is no particular problem here. Oh, I almost made a mistake. It's funny how easy it is to make a silly mistake and you can't see it. I almost wrote down to 10. Maybe because there's a 5 into, I don't really know. But hey, last time I checked, 5 times 5 is 25 over 3y equals 13. Let's combine like terms. We've got 4x minus 10/3, and that's 2/3 x. And then 2y minus 25/3, that's negative 19/3 y equals 13. Look, I understand people do this, and I do it too. I see a number like 19/3, and there's a part of my brain that goes, what is it? Can I be right? And so, hey, you know, no harm, double check. I guess you'd wind up with 6 minus 25, and 25 minus 6 is sure enough 19. Okay. Now, I'm not going to need these two ever again, so let me get those out of the way. Here's the 2 equations and 2 unknowns. Now, if necessary, get a good night's sleep. Eat a hearty breakfast. Don't get this far and go through all that only to mess up this. So this is standard right here. 2 equations and 2 unknowns. I'm going to solve by substitution. Hey, just for fun, I'll start with the second equation here. Remember, you can start with either equation. Let's solve for x. Let's get that over. The negative 19/3 y, we'll add that to both sides. So we'll have 2/3 x equals 13 plus 19 thirds y, and let's divide both sides by 2/3. So what does that give us? 39 over 2 plus 19 over 2y. And we're sort of coming down the home stretch here, but let's put this in for x. Whoa! I almost, remember, you have to put it in the other one. I almost put it in the one I started with. Let's substitute in the other one here. So negative 10 thirds. Let's make the substitution. Oh, I didn't give myself really enough room. Well, that's fine. Do we have enough room? Yeah. Okay, let's do the distributive rule. Now, what you may notice, because it's in the very nature of these problems, it's sooner or later along the problem, no matter how nice the numbers were that you started off with, you may start to encounter some unpleasant looking numbers. Be prepared for that. That's to be expected. It doesn't have to happen. But you know, you look at this and you may start, because I've seen a lot of people like, well, this can't be right. Look at these crazy numbers. No, no, no. Hey, it could be wrong. I could have made a silly mistake, and you're all laughing right now because you caught it. But at any rate, let's go ahead and do this distributive rule. So -1. Whoa. Now I almost wrote down an unreduced fraction, and it wouldn't have been wrong, but I sure could make my life easier. I mean, 2 goes in there 5 times, and 3 goes in there 13 times. So you have 5 times 13. So -65. Oh, just -65. Amazing. Amazing. So I'm just making sure I have the, look, there's some classic ways you can make typographical mistakes. One is your eyes go back and forth. They pick the wrong number from somewhere. Like, let's say I'm going up to this equation here. In fact, I'm making sure I did that right now. I got the -10 thirds and I wrote it there. X, I wrote that. You could accidentally pick off the second term instead of this term. It's incredibly easy to do. Okay. So I did this. We got -65. A little bit of a shocker to me that that's a whole number, but I'll take it. It's like a gift, I suppose. How about this times this? Maybe not so nice, right? So negative, 2 goes in 2 once, 2 goes in here 5 times. What's 5 times 19? 95. So 95 over 3y minus 22 over 3y equals 4. Let's combine these two right here. It's kind of nice. I already have a common denominator. So what's 95 and 22? I think it's 117. And 3 goes into 117. Let me do a little, like, look, you could do this in your head, but maybe at this point you don't want to do it in your head. It's very understandable. If you add 95 plus 22, you get 117 over 3. This is just a little, work that I'm doing off to the side here. 3 goes into 117. 3 times 40 is 120, so 39 times. So that's very nice here. So this is -39y. Okay, that was my scratch work up there, so I don't want to include that as part of the problem. Let's add 65 to both sides. And if I add 65 to both sides, well, incredible. Something's happened. Now, I don't know what's happened. Maybe you do if you're paying close attention. One of two things, maybe both, has happened. Either A, I didn't make the problem up the way I wanted to. It doesn't make it a wrong problem, and it doesn't make it a bad problem. It just means it's a problem whose answer is not a whole number. Or I've made a silly mistake somewhere along the way. Now I'm recording this, so I can't go back. I can't backtrack. Well, maybe I'd have to stop, and who knows? I don't know what, but this is good. Teaching moment, as they say. I can at least look here and see if I made a mistake here. I don't think that I have, but hey, you never know, right? Let's go back. Let's make sure I copied everything down right. -10 thirds, -10 thirds for x. Did I copy this here correctly? Yeah, negative sign, 22 thirds y, 4. Okay, looks like I copied that correctly. Is this time just really 65? Let's see, 2 goes into 2 once. 2 goes in 10 5 times, so you have 5 there. Okay, here, I'll go and write down like this 1. 3 goes in there once, 3 goes in there 13 times. What's 5 times 13? Yeah, that's 65. Okay, so that's -65. If you add 65 to both sides, 65 plus 4 is 69, so that's correct. This part right here, 10 thirds times 19 over 2? 1, 5. What's 5 times 19? That's 95. 3 times 1 is 3. Okay, that's right. What's 95 plus 22? Well, 95 plus 20 is 115. So 117. So 117 over 3. Does 3 go into 117 39 times? Unless I'm really going insane, 3 times 40 is 120. And 1 less is 39. Well, there we have it. Now, I'm going to assume that I, quote unquote, did not make up this problem the way I wanted to. There's nothing wrong with this problem. It is a perfectly good problem. The answer is just not going to come out as nice as I would have liked it to have come out here. So let's go ahead and divide both sides. 3 goes in here how many times? 23. And it's going to be a negative. And 3 goes in there, 13. There's absolutely nothing wrong with a number like negative 23/13. It's a perfectly fine number. In fact, it's very ordinary. I had just wanted this one to come out as a whole number for our first example. So what? So you know what? You're getting a more realistic example right out of the gate. Now, let's go ahead and find solve for x. Let's come back here. Use this equation here. X is 39 over 2 plus 19 over 2 times negative 23 over 13. Now, this is what I really kind of didn't want to have happen for the first example. This is extremely realistic. This is extremely natural. But maybe it's a little overwhelming for a first example. Only you could tell me that. But we'll do at least a couple more examples. Okay, I have to mess around with all these fractions here. Let me get some room here. I guess you can always rewind. I want to keep that value right there. Let me erase this here. I don't want to erase too much. I want to save that, and you'll see why. Don't need that. Let's just go ahead and calculate this. 39 over 2 plus, we don't get any nice cancellation. Now that means that we have to do 19 times negative 23. This is the first point in this course where if you used a calculator, I wouldn't blame you. I wouldn't blame you a bit. Do you need a calculator? No. There's a little sidelight. Let me tell you how I think about this. You could just use a calculator. Do it on paper. Do it in your head your own way. But just for fun, how do I think about this? Well, I suppose it depends on my mood. But in a way, I think, okay, 10 times 23 is 230, and that's almost 20. So 20 would be double that. So 230, double it, is 460. So it's 460, but less 123. So 460 minus 23. What the heck is 460 minus 23? Is 4 what? 460 minus 23 is 437. So this is 437, but just use a calculator. Oh, it is negative. Look at that, negative. And then 2 times 13 is 26. Now we have to do this. And again, I really don't care. I really don't care how you do your fraction. I really don't care how you do that multiplication. And I don't even do it the same way every time, right? And I certainly don't normally talk about it, but I just thought maybe it'd be worth talking about. I don't know. Hey, multiply this top and bottom by 13. And what's 2? It's 26. That's going to be my common denominator. 26. 437. Now we have to do 13 times 39, which actually I find more difficult to do in my head than that over there. 13 times 39. Again, I would say this is a perfectly fine time to use a calculator. Again, if it's me, I'll just show you a little behind the scenes. Since I'm talking right now, it's not really super easy to talk and do these calculations and think about the fact that I'm composing a video all at the same time. But at any rate, the way I would think about this is 10 times 39 plus 3 times 39. It's a little bit easier to think about, and this right here is 390. And this is sort of like relatively easy to figure out, right? Because 3 times 30 is 90, and then 27, 117. So then you have to figure out 390 plus 117, which is how much? Wow, this is weird. I don't usually have in front of being videotaped here. It makes it strangely odd. I think my brain is occupied with other things instead of just quickly doing this calculation here. Again, how do I think of this? Well, I think 390 plus 100 is 490, and then 10 more, it's 500, so it's 507. So this is 507. And finally, remember we're solving for x here. So we have to do 507 minus 37, and that's 70 over 26, but we can reduce that. 2 goes in there 35, and 2 goes in there 13 times, so 35 over 13. All right, finally, we're going to go after z. Now, somewhere along the way, I had a formula for z. I can recreate that formula, I think, pretty quickly here. We subtract these two and divide by 3, so z would equal negative 1/3 minus 2/3 x minus 5/3 y. And now that we know x and y, let's go ahead and put those values in there. So negative 1/3 minus 2/3 x is 35 over 13 minus 5/3 and y is negative 23 over 13. And we have to calculate this. This actually is a very good example to show you naturally how these play out. And they don't play out very nicely. But I've got some good news coming up here. Relatively good news. Let's go ahead and do this calculation. See, it looks like a daunting task, but we can do it. Negative 1/3 minus, notice we don't really get any nice cancellation here, do we? So 70 over 39 plus negative times a negative. Can I read my own writing? This just got scary. That's a 13. Yikes. Almost couldn't read my own writing. No, so we don't get any nice cancellation. So plus, what's 23 times 3 is 115 over 39. Let's use 39 as a common denominator. I can multiply this top and bottom by 13. So 13, 39. So negative 13 minus 70 is what? Negative 83. And negative 83 plus 115 is 32. So 32 over 39. Whew. Now you see why I said I only want to do one example. These are the pinnacle of skill building problems, because on top of dealing with fractions, distributive rule, combining like terms, solving linear equations, they help build endurance. That's sort of a mental toughness or resilience. What's the term everybody loves using these days? Grit. You have to have some level of confidence. Yes, I'm doing this right, because the numbers may look quote unquote strange. You get used to that after a while. In fact, you become more shocked when the numbers are not. When the numbers come out as whole numbers, you almost think you've done something wrong. Okay. Now, what's coming up? There are other ways of solving these problems, and I'm going to deal with those in the next video. This I consider indispensable. This I consider you have to know. I'm going to have you do a problem like this. I'll do a couple more. I'm going to make an announcement about Zoom. Zoom will start this week. I'm all set up, all ready to go with Zoom. I'm going to post on the announcements. I think for Zoom, I think I need your email, because I'll send you all an invite, so to speak, at a certain time. The Zoom is entirely optional. It's really for you to ask me questions. They could be questions from the book. They could be questions about videos. They could be questions about, just the topics in general, problems from the book, etc., etc. It's up to you. So come to Zoom if you want. You don't have to. I'm not taking attendance on Zoom. But if you want to be on Zoom, it would be really great if you had a question. So you can chime in and ask a question. There are many methods for solving systems of equations. Let me just tell you what they are now. In the next video, we'll go over them. One is something called the elimination method. Process of elimination. And most people, you'll find they love this. I don't. In fact, I never personally use it. And I'll tell you why in just 1 second. The other method is have the computer do it. How do I have the computer do it? I go to Google, I type in 2 equations, 2 unknowns. You won't get that typed in before autofill beats you to it, because 2 equations and 2 unknowns happen so often that so many millions of people would like to have some software that would just solve it for them, whether you're an architect or an electrical engineer, that it's there. I only use sites that are free and that are easy. If it's not user friendly and it's not free, I don't bother with it. But mostly, I'm just looking for something that looks like this. And whoops, yeah, sorry. And you fill in the blank space. Click solve or something like that, solve or calculate, and it'll give you the answer. Now, why don't I use the elimination method? This is a sort of a quasi shortcut, a partial shortcut. It's really a pseudo shortcut. It's not the quickest method anyways. It's not really the method the computer uses. We're not going to go over the method the computer uses. So if I want to work a problem out by hand, I tend to gravitate towards substitution method because it's good for building your skills and practice and all sorts of good things. If I just need an answer really, really quickly, just right now, give me the answer so I can move on to something else, I fire right ahead of the computer. There's one other topic that we need to touch upon, and that's matrices. And we will. We're not going to get very deep into matrices. If you've had some contact or experience with matrices before, you may love them or hate them. That's up to you to love them or hate them, but we're going to talk about them. But I don't do them by hand. If you're a computer, you'd love matrices. It would be right up your alley. But as a human, I don't really care for them. I like what they do for me, but I don't like calculating with them. But I do want to show you how, and I do want you to know how to calculate with them. Okay. So look at the announcements, because I'm going to post some announcements concerning, when Zoom is going to be. Again, Zoom is going to effectively be office hours. So you ask me questions, and then we'll go over them, or I'll go over them. And we can have a little bit of back and forth. Okay. Next video, we'll wrap up chapter 4, and the main thing to be discussed yet, that has not been discussed yet, really, is matrices. And like I said, I don't want to go too crazy or go too deep on matrices, so we'll try to keep that relatively tame. Okay, so that's enough for this video.